This is Algebra 3, Properties of Rational Exponents. And the first thing we're going to be looking at is just a reminder of some of the rules related to exponents. So I'm going to start off with this rule where we have some base a and some power m, and we're multiplying that by the same base and another power n. M and n might be equal, they might not, I don't know. A here is definitely the same a as there. That's required. So when we do that, what we can really remember is that powers, when we say a power or an exponent, what we mean is that we're multiplying the base by itself over and over again m times. So however many times this is, it's going to go on, and then there's going to be times another a, and there will be m a's there. Hope that makes sense. And the other part is there. But first, I should say, I'm going to put this multiplication right there. So it's in black. The other ones are in blue. And then now when we're looking at a to the n power, what we're saying is we are multiplying a by itself now n times. So however many, whatever number n is, there will be that many a's. So looks like that. So if you think about it, if we take this whole thing, so I used blue and red there, and that was actually an accident, but I'm really glad that I did, because if you think about it, what we have is we have a multiplied by itself, m, oh, let me do this, m plus n times. So we're multiplying a by itself, m plus n times. So really what we can do is this is equal to a to the m plus n. So we don't have to write this out like this. We can just go straight from there to there, and that'll be fine. So as an example then, let's think of something like a to the second power times a to the third power. Well, that's going to be a to the power 2 plus 3, which will equal a to the fifth power. So notice that it's a to the fifth power. Sometimes people get confused and they do like a to the sixth because they're multiplying those exponents. But if you remember this explanation, this would be a times, why don't I actually show it here just to be really, really clear. This is a and then times a. So this right here is a times a. And then we have this multiplication right here. And then this a to the third power is a times a times a. So we can see that this is 2 a's. This is 3 a's. So if we look at all of it together, what we have is a to the 2, well, I have it right up here, a to the 2 plus 3, which is a to the fifth. Does that, how are we with that? So far, so good? All right, good, good. So the next thing that we are going to look at is if we're talking about rational exponents, so, or radicals even, being the same as rational exponents, I'm going to start with something like x to the power 2/3 multiplied by x to the power 1/2. Now this is going to require some fractions here, so don't get scared. Fractions are just numbers. You may forget the rules of fractions, but we can go back and look at those, and I have a couple videos for that as well. So this x to the 2/3 times x to the 1/2, we can rewrite as x to the power 2/3 plus 1/2, because that's the rule that we learned up there. That's the rule we learned. So now, though, we need to remember that when we add fractions together up here in the exponent, we need to have a common denominator. And the common denominator we can get by multiplying this fraction by this base over itself, so, or the denominator, 2 over 2. And we multiply this fraction by this denominator over itself, 3 over 3. So what we'll get is x to the 4/6, because we did 2 times 2 is 4, and 3 times 2 is 6. So we're just changing the way the fraction looks, not its value. And then we're adding to that. We're going to multiply this one by 3 over 3. 1 times 3 is going to be 3 over 2 times 3 will be 6. Right? And if you feel frustrated with some of that, we can work on that later for sure. But now that we have these two fractions in the exponent that have the same denominator, we can just add the numerators. So it'll look like this, 4 plus 3, and they share the denominator now, 6, which is x to the power 7 over 6. And that is our answer for that problem. So we started off with these bases that are the same, raised to rational exponents. Remember, rational means fraction. So they're exponents with fractions. And that's all we're doing there. And we could convert this into a radical if we wanted to. And the radical that we would convert it into, well, remember that the denominator becomes the root, so it's root 6, written like that. And the numerator becomes the power on the base underneath that radical. So it's root 6 of x to the 7th power. And I want you to practice that kind of language. It's really important to use math language there. All right? Questions so far? Now, similar to this, you know what? I wonder if I should stop here and do another video because we're at 8 minutes. I think so.